right, we're going to be looking at section 11.3, which is talking about events that involve and. So we're going to be talking about something called conditional probabilities, events that involve and. And so what we're going to be talking about first is conditional probability. So what happens with conditional probability is you're trying to look at the event that something's going to happen only if something else also happens. So for example, the possibility that I draw a red marble out of the bag and then draw a blue marble. So it's conditional. It's dependent on the first condition happening. So the probability of an event B computed on the assumption that event A has already happened is called a conditional probability. And we read this as P, the probability of B given A. So the formula for this is read this way. The probability of B given A is the probability of A and B happening. So we have to look at what would be the intersection of those two things. And then we divide that by the probability of just A happening. So let's look at an example so it makes a little bit more sense. So we have this sample, 2, 3, 4, 5, 6, 7, 8, 9. A single number is going to be randomly selected, and the following events have to occur. A is that the number is odd, and B is that the number is a multiple of 3. So if we look at these probabilities here, the probability that the number is odd, in my list there are 3, 5, 7, and 9. So there are 4 numbers in my list that are odd, and there's a total of 8 numbers in the list. So the probability that it would be odd, so the probability that A occurs is 4 out of 9. Okay, that makes sense? Then B. B is the selected number is a multiple of 3. Oops, I messed up here. This should be 4 out of 8. Sorry, I counted wrong. I didn't think I did something right. Okay, so 4 out of 8. All right. So now the selected number is a multiple of 3. So multiples of 3 in my list are 3, 6, and 9. So the probability of B by itself is 3 over 8. Okay, so now we're going to look at these answers down here. So the probability of B we just talked about is 3 over 8. The probability of A and B. So now what we have to look at is our list up here of what we have circled for A and B and see what they have in common. So the overlap, the intersection, A is and is intersection, the intersection of my 2 lists up here that I have underlined in red, and circled in green, there are 2 overlaps there. So the probability of A and B is the set of numbers 3 and 9. So again, those are the numbers that have that are odd and multiples of 3. So my probability of that occurring is 2 out of 8, which is 1/4, but we're going to leave it as 2 over 8 right now. So the probability of B given A, if we use our formula, is going to be 2/8 divided by the probability of just A, which is 4/8. So this would equal 2/8 times 8 over 4, which is 2 over 4, which is 1/2. Okay. Now another way of looking at this is the probability of B given A. Well, A is only the set of odd numbers, so I have, my list has been reduced down to 3, 5, 7, and 9. So the probability of B, the intersection we already decided was 2, so we would have 2 over 4, and that also reduces down to 1/2. So let me give you some another page with some answers. So here's our answers again. So the probability of B was the numbers 3, 6, and 9, so the probability of B was 3/8. A and B, this is the set of A values, this is the set of B values. So we're going to go through and look at the intersection, which means what do they have in common, and what they have in common are the numbers 3 and 9. So the intersection of A and B, the probability of that would be 1/4 or 2/8. So again, the condition that we're talking about, that A has to be true, reduces our list to 3, 5, 7, and 9. So that means that the intersection is 2/8 or 1/4. So I have that probability, which is again 2/8, divided by the probability of A, given that formula, which again we talked about was probability of A was 4/8. And we reduce that to 1/2. Okay, another way of looking at this is what I was going to show you here. The probability of A and B, which is 2, divided by the given set A. The probability of the given set A is 4, and so 2/4 is 1/2. So you can look at these problems either way. Sometimes I think the formula is a little bit easier. All right, so here we have a family with 2 children. Find the probability that both of the children are boys, given the fact that at least one is a boy. So when we're looking at our probabilities here, all the different cases, I'm going to go ahead and show you the answers and I'll explain it. All of the different cases that I could have would be girl, 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 boy, boy, girl, and then boy, boy. Now the cases of A is that at least one of them is a boy. So that would eliminate this first choice over here. And so my choices would be girl, boy, boy, girl, or boy, boy. Now what do I want? What is the ideal situation that I'm saying I want are 2 boys. Okay, so let's look at this. If I look at this case here, B, and I look at case A, and I figure out what do they have in common, the only thing they have in common is one case. They have this one case of boy, boy in common. So there's a 1 in 4 chance, given that overlap, that it's a boy and a boy. Now the probability of A is 3/4, right? Because I have 3 cases in A out of 4 total possibilities. So if I work this problem out, and remember your math, you have 1/4 divided by 3/4, so you have to take the reciprocal. So 1/4 times 4/3 works out to 1/3. Okay, so again, the other formula that I was talking about is a little bit more obvious here. The probability of B given A. So if we look about this, the probability of B is 1. The probability of A is 3. So again, here's where that 1/3 comes in. So two events, A and B, are called independent events if knowledge about the occurrence of one of them has no effect on the probability of the other one. So in other words, the probability of B given A is the probability of B, or the probability of A given B is the probability of A. These are called independent. So many times you might ask to decide whether or not an event is independent or not. And so we can look at an example here where we're trying to figure that out. So a single card is to be drawn from a standard 52 deck of cards. And we want to figure out whether this is an independent event or not. Or, yeah, whether it's an independent event. So the card selected is an ace, and the selected card is red. So aces, there are 4 aces in the deck. So the probability that it's an ace is 4 out of 52. The probability that the card is red, there are 26 cards in the deck that are red, so it's 26 out of 52. So the probability of B, and I'm not going to reduce my fractions yet, I'll reduce in the end. The probability of B is 26 out of 52. The probability of B given A, so what I have to do is look at this and say, if I look at all the red cards and all the aces, how many overlaps are there? So I want to see for this part of the problem, I need to know what is P, the probability of A intersect B. So I need to know how many red aces there are. Let me guess. I need to know how many red aces there are. So there are 2 red aces out of a possible 52 cards. So the probability of A intersect B is 2 out of 52. So the probability of A intersect B is 2 out of 52. And I want to divide that by the probability of A, which is 4 out of 52. So I end up with 1/2. And this also ends up with 1/2. So determining whether or not those events are independent, since I ended up with 1/2 for both of them, they are independent. So if we look at this, the probability of B we just figured out was 1/2. The probability of B given A we figured out on the other screen was 1/2. So since those probabilities are the same values, these are considered to be independent cases or independent events. Okay, so if we multiply both sides of the conditional by a piece of A, we obtain the expression for PA and B. And the calculation is simpler when they're even independent. So let's look at what I mean by this. So we already made the comment, we just made the comment a minute ago that the probability of B given A equals the probability of B if the event is independent. So when it's independent, the probability of A given B is the same thing, I'm sorry, of B given A is the same thing as the probability of A intersect B divided by the probability of A and so what I'm saying here is that that's the same thing as the probability of B. So if I think in terms of cross multiplying, then what I have is the probability of A intersect B is equal to the probability of B times the probability of A, which is what we have right here, because the word and, we can use the intersection symbol for it. So that's the probability of A is equal to the probability of B. And that's when the two events are independent. When they're not independent, it's a little bit different, but not that much more. Okay, so here we have Jeff draws balls from a jar below. He draws 2 balls without replacing them. So that means that we started off, if we look at our numbers over here on the left, we started off with 9 balls in the jar. If I draw one out, then I'm now left with 8 balls in the jar. If I draw another one out, I'm left with 7. So he wants to know the probability that he draws a red ball and then draws a blue ball in that exact order without any replacing. So if we look at that, the probability that he draws a red ball the first time through, I'm going to go back for a second. Since there are 4 red balls, the very first draw means that I could draw 4 possible balls out of 9. But now I don't have 9 balls in the jar anymore because I just drew one out. There's only 8. So the possibility of drawing a blue ball the next time around is 3 out of 8. If I were to come through and say, right now, what's the probability that the third one I draw is yellow? Well, there's only 7 balls in the jar now, and so it would be 2 out of 7. Okay, so if we go back to that screen, so the probability of drawing a red ball and then a blue ball would be the probability 4/9, because there's 4 balls out of 9, and then the probability of the blue would be 3 balls out of 8. So then we just simply do our math, and we have 12 over 72, which is 1/6, which is 0.1667. Let's look at one more. So this time he draws the balls from the jar, but each time he draws the ball, he writes it down, and then he puts it back in and draws another one. So that means that there are always going to be 9 balls in the jar. So the probability of drawing a red ball at any point in time is going to be 4 out of 9. The probability of drawing a blue ball is going to be 3 out of 9. The probability of drawing a yellow ball would be 2 out of 9. So I want to know what's the probability of drawing a red one and then a blue one. So I'm going to say the probability of the red ball is 4/9. Probability of the blue ball is 3/9, which is 12/81, or 12 over 81, which is 4 over 27, which is 0.148. All right, I hope this helps. Again, keep up with your work. Call me, email me, text me if you're having problems. Don't let yourself get behind on your work.